We are going to show the operating principle of the AccuFlow Series 1000 hydraulic diaphragm metering pump using a cutaway driver with an electric motor at slow speed controlled by a VFD. At this speed, you'll be able to see the internal parts and how they function. The motor shaft turns the worm shaft in a clockwise direction. The worm shaft turns the worm gear. The worm gear is connected to the crank, which in turn is attached to the connecting rod assembly. The connecting rod assembly pushes the piston in and out. Each cycle of the piston moving forward to develop the pressure and backward to refill the cylinder is called a stroke. The capacity of the pump is determined by a diameter of the piston and the strokes per minute, which is the frequency of the strokes. When the oil is pressurized with the piston's movement forward, that pressurized oil is pushed through a spool valve, which is the integral part of the stroke adjustment assembly. This valve determines the effective length of each stroke based on the adjustment knob's position, usually represents in terms of value between 0 and 100%. The hydraulic oil is then transferred to the back of the diaphragm, which flexes back and forth, drawing in the process liquid and discharging through it the check valves. AccuFlow pumps also have a built-in relief valve, which is essentially a safety feature. It prevents overpressurization, leakage and rupture in case of a clog or closure of the discharge line. Usually the internal relief valve, which is also referred to as an IRV, is set at a pressure higher than the operating pressure by 10% or 20%. So if there is overpressurization in the IRV, will open and recirculate the oil internally. In this video, we use the actual pump using an acrylic head to show the diaphragm moving and liquid being pumped. In order to show the diaphragm, we remove the contour plate, which is normally in front of the diaphragm.
Diaphragm.